Talagang wala talaga. Ayaw talaga nila. O sige na nga, pakita mo na nga ang question, sagot sa question. So there could be two things, M protein or mycolic acid. Okay? So these are pathogenic determinants. If this doesn't look familiar to you, these are pathogenic determinants. Okay? Kind of looks familiar, right? These are pathogenic determinants. M protein could be found on, hang on a sec. M protein could be found on Streptococcus species, Streptococcus pyogenes. It prevents phagocytosis. Mycolic acid could be found in the cell walls of Mycobacterium, and it prevents intracellular digestion. Okay? So, prevention of phagocytosis. Sir, may difference ba ang phagocytosis at saka intracellular digestion? The process of phagocytizing another organism via hang on a sec. Ba't parang hindi siya nakikita sa ano natin? Let me go here. Let me just go and fix something. Okay? So yeah. So we have those two things, okay? So pathogenic determinants. So these could be pathogenic determinants, by the way, for Streptococcus species and for M protein and mycolic acid for Mycobacterium. Okay, so sir, bakit ano ba pinagkaiba ng phagocytosis at intracellular digestion? They sound interchangeable. The phagocytosis is basically the process in which there are the four steps, by the way, right? Detection, active ingestion, and then intracellular killing, as well as dissolution, right? So intracellular killing is by maybe the fourth stage of phagocytosis, or the fourth step in this process of the phagocytosis, and you'll study all of this when you go to immunology. The four processes that undergo when a foreign body gets ingested by a macrophage or macrophage organism. Okay, next slide, please. There are some organisms that lack a cell wall in their cytology, and yes, they do ask this. They do ask this in the exams that you might take. Okay, there's two of them, by the way. Who knows the answer to this question? It's important. You have to put a star on this slide, by the way. There are two species of microorganisms, or bacteria rather, that lack a cell wall structure, making them blank, which is the second bullet in that particular slide. Anybody know the answer? Again, I put two at the side over there, meaning there's two of them. Who raised their hand? Marion. Moyo. Tarin Moyo.
Ano po? Di po ba mycoplasma species po?
Bakit hindi sure?
Po,
Bakit hindi sure? Okay. Mycoplasma. Okay.
dahil po ano po siya, sir, pleomorphic po siya.
Ano pa?
Ay, dalawa ba?
Dalawa siya.
Isa lang po alam ko, sir.
Okay, so
Mycoplasma kasi po pleomorphic po.
Okay, so you have to remember, yes, the answer to the next bullet was also answered there by Moyo in his statement there. That is correct. The other species is ureoplasma. Can you show the next slide? So first slide is mycoplasma species. Second slide. Okay, so next slide, Patrick. Thank you. Okay, so mycoplasma is the first one, and then the other one is ureoplasma, or ureaplasma, sorry. Okay, so you could have mycoplasma pneumoniae, ureaplasma ureolyticum, okay, and then the terminology for the terminology that happens to when something has no cell wall, making the microorganism malleable, or it changes in shape depending on how you depending on how it was fixed the moment it was placed on the slide, is pleomorphic. So pleomorphism, it could be like imagine doing jump shot. when you're taking a picture of your friend. Hi, jump shot tayo, mag-picture tayo, ano Patrick, tatlo tayo, talon tayo sabay-sabay, 'di ba? So si Patrick pwedeng nandun sa taas during that time because when you're fixing a sample on a slide, it's basically as if you are taking a snapshot of a particular moment in time. So you freeze time for that particular organism. Okay? So when you freeze time for that particular organism, it retains the shape of what it was the moment you fixed it. So hence the analogy of me with Patrick jumping before before you press that button that says take a snapshot. Okay, so that's basically it. Okay. So yun jump shot. Mas mataas yung talon ni Patrick kasi mas malaking mama siya kaysa sa akin, di ba? Ganon. Hindi dahil wala siya cell wall. Charing lang. Okay, let's go down to the next slide. Alright, I think, wait, there's a problem with my live stream. I think it's not showing the first few slides. Let me first fix that before I continue. Okay. Before I continue on and blab about this particular lecture. Okay. All right. Slideshow. So tayo? Slide 4 na? Okay. So, I think that's it. All right. Cool beans. Okay. Now, let's continue on with the next slide. I think we're in slide 4 now. Patrick, what is the main constituent of the bacterial cell wall? The main constituent of that bacterial cell wall, please don't forget, kung meron na kayong makakalimutan, wag lang to, peptidoglycan. Okay? There are constituents that make up this particular structure, peptide and glucose, or a sugar molecule. So peptidoglycan, biochemistry nomenclatures. Right? So you'll have N-acetylglucosamine and N-acetylmuramic acid. Okay? Your carbohydrate is acetylmuramic acid. Okay? Sorry, your peptide, is your peptide is an acetyl. All right? Okay. Next slide, please. We are at number 5. Number 5. We'll go with number 5. What test is used for differentiating bacteria based on the components of their cell wall? This is what I told you guys earlier. And there are reagents and their purposes. Who can answer this for me? Napakasaya nito. Okay. Wait, hindi ko nakita yung nagtaas ng kamay. Sorry. Hindi ko nakita ko sino nagtaas ng kamay. Sino yun? Let's go with Aljabar Sahi. Assalamualaikum.
Crystal violet, sir.
Okay.
Crystal violet po.
Okay.
As primary stain.
What's the test first?
Important po is
Wait. Chill out.
drum staining.
Okay, very good. Chill ka lang. Okay. Continue na tayo. Reagents. Let's start with number 1, crystal violet.
Yes
Okay.
po. Tapos po, grams iodine po. Tapos alcohol po. For decolorizer.
What type of alcohol? You have to be
Tapos po
specific. What type of alcohol?
Ethyl alcohol, sir.
Ethyl alcohol, ilang percent? That's what they ask in the exams. So, di pwedeng kulang. Ilang percent? Grabe naman to si sir. Ilang percent?
Hindi ko matandaan, 10%.
Oh, 10%. Grabe naman 10%. Hindi yan didikit. Hindi yan mawawala. Okay, sige. Alcohol. Mamaya tayo sa ano. Okay. Number 4. Fourth reagent.
Tapos sir, safranin po for contour stain.
Okay, so who can answer that question? Who can answer the next question? My next question. Alam niyo na kung anong next question ko. what is the reagent? What alcohol are we going to use? Sandali ako nawala. Wait. Hindi ko nakita kung sino yung nagtaas ang mic. Okay, let's go with Marianne. Vanice Castro.
Sir, rinig po ba?
Yes, I can hear you. Yeah, girl.
Ano po? 70% ethyl alcohol po.
Okay, wonderful. 70%? Oy, mali. Oy. Pamaya ka na, Moyo. Si Maria Therese muna tayo. Baka sabihin meron ako, favoritism.
95% po.
Very good. Before you put down the microphone, or turn off your microphone rather, what other alcohol can be used as a decolorizer in grams iodine? In grams
Acetone.
acetone alcohol. Very good. Acetone alcohol. All right. So let's show them the answers. Is Al-Jabbar correct in everything? Next slide, Patrick. Hindi active si Patrick next slide. Sakaling kita, Patrick.
Di ba lumatak sa conversion?
Hindi. Ay, ayan na pala. Ayan. Okay. Alright. So, this is the most basic, by the way, class. If there's something important that you must not forget, it's this one. Okay? Name of the reagents, chronological order, what the test is for. Okay? That's the most important thing. If there's something that you must learn today, this is it. Gram staining. Okay? Ano ba ang mga results na makikita natin when we're gram staining? Sige nga. Ano ba makikita natin results? Let's start from the back. So Sir Marco asked me to, because we have such limited time, Sir Marco asked me to keep the pace a little bit faster. Okay? So what is the most important thing that we need to remember when we're doing gram stain? We want to know if the organism is what? A gram-positive organism or a gram-negative organism. Sorry, naunahan ko na kayo. Okay? So it's either gram-positive or gram-negative, di ba? At if you look at every chart, nag-intern naman na kayo lahat, di ba? Right? Tama ba, Patrick? Ikaw ang tatanungin. Ikaw ang co-host ko, kumbaga. Ang dami kong trabaho pala, sir. Kailangan kong mag-respond.
Intern naman na po na lahat.
Nakapag-intern na sila lahat, no? So, di ba makikita nyo, meron usually mga algorithm, yung mga there's an algorithm. Like it always starts at gram staining. Gram positive or gram negative? Gagay mo doon. Is it a cocci or bacilli? Yes or no? Di ba may mga ganon? Is it catalase positive or coagulase negative? Yes or no also, di ba? It is the start of everything. Do not, I repeat, do not take the, what do you call this? The importance of gram staining for granted, class. Okay? Even in hospitals that have a lot of technology, class, gumagamit pa din ang mga hospitals ng gram staining. Right now, I thought we won't do anything of the sort. Nung nagpunta ako dito, maski nung nagpunta ako ng Saudi, kasi social yung mga mga machine, 'di ba? Maski nung nagpunta ako ng social ang mga machine, pero one thing that didn't change, even though the other methodologies for identifying microorganisms have changed, is the very first step, which is gram staining. Okay? That is the most important step for you guys as med. If you guys want to pursue a career in the department, or if you want to focus on your career towards microbiology, gram staining ang important. Okay? Sinasabi ko na sa inyo ngayon kasi class may mga katrabaho ako. Hindi sila marunong magpasa ng gram stain. Okay? Okay? Alright. Okay, so we have to indicate the reactions of a gram-positive organism and a gram-negative organism. I know, paulit-ulit ka, sir, pero I would have to ask the question, anong color reaction ng gram-positive na organism from a gram-negative organism? Moyo.
Sir, pag gram-positive po, purple po. Pag gram-neg po, pink.
Pwede ba natin gamitin dark purple? Kasi last time when we talked about something in histopathology, nagkaloko-loko tayo. Pwede ko sabihin dark purple? Moyo?
Ang alam ko dun sa, ano po kasi nagawa ko pong notes, sir. Ang color po dun is, sinilagay ko po is violet or purple. Then pag negative, red or pink.
Very good. So, at least meron kang range. Okay? Hindi yung fix lang. Alala ko, nag-histopath tayo. Laking kaguluhan ng ng acid hematin eh. Okay. Alright. Just making sure. Okay. So, these are the colors that you might get. For number 1, that is gram-positive. It's violet to, can you show the next slide? Sorry. So, number 1, that's for gram-positive. Kaya may label yun. Violet to purple, red to pink for gram-negative, which is number 2. Next slide. Okay, so we have to know, since we're talking about the method, since we're talking about gram staining, we mustn't forget the step before actually staining the sample, which is fixating the sample or fixation. Not fixating, iba yung fixating. Bata pa ako, yan yung ginawa ko tong slide na to last eh. Hindi ko na nabago yung grammar. Okay? What are the most common methods in fixing a specimen on a glass slide? Marian.
Heat fixation po, tsaka yung slide method po.
Diba? Ang arte, no? Slide warmers. Ang arte, diba? Okay, so what's the most important? What's an example of heat fixing a specimen? Give me an example of heat fixing a specimen, class. You guys remember your show the answer, Patrick. Whilst I'm asking the class, heat fixing a specimen. Practical labs tayo. Practical tayo. Anong ginagawa natin para ma-heat fix ang isang slide? At saka pwede bang mag-heat fix sa sa bacti cell? Hindi ba mamamatay yung mga microorganisms? Marian, sige. Hello?
Sir, sa heat fixation po, pwede siyang gamitan ng Bunsen burner.
Oo. Pero heat fix hindi mo pa iitimin ha, Marian ha. Baka magkaroon padadaanin mo lang, Marian ha. Pagkasabi mo kasi ng Bunsen burner, parang isusunugin mo na yung okay, hindi sa laboratory hindi ka nag-aano, Marian naman. Bunsen burner, sir. Pwedeng padaanin. Gaganin, dadaan mo lang sa slide. Nakikita niyo ba ako sa video?
Ganun lang.
Idadaan mo lang sa slide. Pagkasabi mo ng heat fixation, Bunsen burner, sir. Sinunog. Sabi kasi ni Sir Manuel, Bunsen burner. Iginano niya doon. Nag-ihaw si Marian. Okay, next slide. Okay, so the most critical step in gram staining. This is a question in both ASCP certification for MLSs. I remember this was one question that was asked of me. The most important step. Okay? Who here knows the most important step or the most critical step in gram staining? Tama na si Moyo, masyado na. Si Aaron Kirby naman, baka sabihin meron akong favoritism. Maya-maya ka na ulit. Nasaan na yun? Aaron. Hi Aaron! Nagre-recite pala to si Aaron. O sige, ano yung
decolorizing po.
Very good. O sige, dahil sumagot ka ng decolorizing, ano ang mga reagents na pwede natin gamitin as a decolorizer? Mention ko lang kanina. Tingnan nga natin kung nakikinig sa akin si Kirby. Si Aaron Kirby. Mariano. Nako.
Counted po ba ang ethanol?
Aha. Pero ilang percent? Ayan na naman tayo sa ilang percent. Ilang percent? Huwag ka magsasagot ng 10%, hindi mabubura yun, ha?
95 po.
95, very good. Okay, aside from 95% ethanol, what other chemical can you use as a decolorizer? Aljabar.
Yung acetone alcohol po.
Very good. Okay? So don't forget that these two could be changed. This could be interchangeable. Okay? Alright, so the most critical step, show them the answer. Let's see if they're correct. We're correct in answering number 8. Okay? Hello? Nasaan na si ano? Ayan, decolorizing. Okay, the decolorizing step is the most important step. Bakit, sir? Bakit siya ang pinaka-important? Kasi, class, ganito ang bibigay ko sa inyo, bibigay ko sa inyong scenario. For example, na-overstay mo siya. Medyo matagal-tagal siyang na-overstay. Matagal-tagal mong nilagay yung Siyempre, for example, kami ni Patrick, magko-intern kami. Siyempre, siya co-host ko, siya lagi ko gagamitin. Magko-intern kami. Napasarap ang chika namin, nagchichismis kami ni Hay, alam mo ba, jowa ni Marian si ganito. Ganon, di ba? Huwag ka mag-alala, girl. Hindi ba ito, buong araw kitang pagtitripan, girl. Chill ka lang. Ikaw yung isa sa mga every year meron ako pinagtitripan. Huwag ka mag-alala, girl.
Pinabubunot mo ako.
Oo, ganon. So, Patrick, may chismax ako. Mag-jowa daw si Marian at saka yung intern sa kabilang school. Ganon. So, napasarap ang chika namin. Di ba? Napatagal ang Crystal Violet. Sabi niya, papatayin ako, madidemerit ako. Okay? So, ang gagawin ni Patrick is, syempre, mas senior ako na intern at syempre, mas bright at pretty ako kay Patrick. Sabi ko, tagalan mo lang yung decolorizer. Aayos din yan. So, gano'n ang ginawa. Hindi namin sinabi sa staff. Diba? Kinabukasan ang tumubo, gram positive talaga. Okay? So, nabasa ni staff that day, gram positive naman pala. Okay. Nilagay ng staff, gram positive. Okay? So, what's the lesson there? Okay? You can actually modify it based on your own preference. Yung decolorizing step, you can modify it. Mapasobra ka man sa crystal violet, mapatagal man ng crystal violet, pwede mo siyang i-modify in your own terms. Okay? Pero yung decolorizing step, yan ang pwedeng, hindi pwedeng palitan. Yung tagal. Okay? Yung decolorizing step pala ang pwede mong tagalan or babawasan. Yan ang pwede mong i-modify. Okay? The other ones, pag na-modify mo, pwede ka pa magkaroon ng magkamali. Okay? So, let's say, for example, sinunod pa din ni Patrick yung procedure na 10 seconds lang. Pero sobrang tagal ng crystal violet. Ang nakita ng staff is gram positive. False. Ang nakita let's say gram negative ang organism. Kaya theoretically, the organism is gram negative. Since nagchika kami, pinagchismisan namin ang buhay ni Marian. Diba? Tapos sinunod pa rin ni Patrick ang procedure na 10 seconds. Siyempre, di ba mas makapal yung kumapit na crystal violet? Natakpan ngayon yung gram-negative na organism nung dinicolorize. Kasi same time pa rin ang ginamit niya, hindi niya minodify ng konti. Okay? Ganun yun ang pwede mangyari. O let's say, for example, naman counterstaining naman ang problem. Ano naman ang problema, sir, kung napasobra? Wash with water mo siya. Okay? If gram-positive talaga ang organism, tagalan mo yung wash with water na last step natin. Gram-positive ang organism talaga, gram-positive ang makina. Medyo mas marami lang yung debris ng And it requires a little bit of experience when you look at these things. Okay? So, may mga questions na dadating sa inyo. It was falsely, you'd get a case study. You'd get a case study that the same thing that could be, the same thing. The laboratory assistant was staining it. Unfortunately, he got held up. He forgot to wash the sample whilst he was decolorizing. And the next day, they saw gram-negative organisms. And in the previous result of the gram stain, the staff saw gram positive. What do you think would be the problem? You have to be able to troubleshoot things. At the back of your mind, you have to know, napasobra ng napasobra yung time ng primary stain. Okay? Or paano naman sir kung ang problem na na-receive ko is about mordant naman? You would see black precipitates naman. Okay? You would see black precipitates. Okay? Kasi ano ba ang color ng anong color ng iodine once it reacts with crystal violet? It will turn black, 'di ba? Or grayish. Okay? Kung hindi mo na decolorize ng tama, may makikita ka mga precipitate. Okay? Alright? So yun yung tinuturo ko sa inyo ngayon, class. Okay? So the most important, that's the reason why it is the most important step. Because you could tinker around with the timings with decolorizer, the specimen, just if you know that there was a mistake at the previous steps, but not the other way around. Okay? Alright, so let's go back to our discussion. This is the component of the cell wall of bacteria that binds to magnesium. Ako, meron bang ganyan, sir? Anong kalokohan yan, sir? Don't forget teichoic acid. Okay? Teichoic acid. Teichoic acid binds to magnesium, and magnesium is an important electrolyte or an important element for bacterial physiology. Don't mistake it with teichoic acid, which we'll talk about later. Teichoic acid, TE. Okay? Teichoic acid is a different one. Okay? Now, let's move on to the next thing, which is, I think, has something to do with the structure of microorganisms. Okay? Structure of gram-negative microorganisms, rather. Okay? So, with the structure of gram-negative, structure of gram-negative bacteria is different because of what? The structure of gram-negative bacteria is different because of what? And what other names can be associated with that particular structure, and what structures may be present in gram-positive that is absent in gram-negative bacteria. I put everything in that slide, and please put a star on it, because this is something that they ask in the exams. Sometimes it would pop up. Okay, so the structure that's present in gram-negative bacteria is the lipopolysaccharide bilayer. I know ang haba. There are other names to it depending on what microorganism you might get. Okay, so it could be the O antigen, it could be the core antigen, or lipid A, quote unquote endotoxin. Okay, for gram-negative bacteria, what makes it different from gram-positive bacteria is that the lipid bilayer has two structures. This is teichoic acid, hindi teichoic ha, teichoic naman to, and lipoteichoic acid. That is for gram-negative microorganisms. Okay? That is only present in gram-negative organisms. Or sorry, that's absent in gram-negative organisms. All right? Let's move on. Okay. We're going to delve deep into the exams. We're going to delve deep into the examiner's mind now. All cocci are gram-positive except 4. Okay? Meaning, what am I asking here first? Who here before answering the question, ano ang tinatanong dito? I want you guys to think as an examiner here. Ano ang tinatanong ko? All cocci are gram-positive except 4. Kasi madaming students na nagkakamali talaga lagi. Natatrap talaga lagi sila. Lalo na pag hindi ko binold or initalize yung isang word. Ano yung lagi kayong natatrap sa akin? Kasi examiners do that also. Marion, ano yung problem natin lagi? Di ba pag nagrarasyo tayo, lagi, may problem tayo lagi. Ano yung lagi ko sinasabi sa inyo, class?
Sir? Intindihin po yung bawat question.
Right. And in this question, what am I asking? All cocci are gram-positive except 4. And then...
Sagutin ko po ba, sir?
Yeah, sure. No, wait. I want you to answer what I'm asking for. Not that specific line. Okay? I want you to explain to me what am I asking for. Because right now you come to my class with me assuming that you've already did the theoretical work, the studies theoretically in your third years, right? But what I'm teaching you guys is how to be better examinees, right? So ano yung tinatanong ko, Moyo? Okay, may nakakaalo na. O sige, si ano naman. Mamaya ka na Al Jabbar ha. Si ano na muna. Si Peter John muna. Sige. Ngayon ko lang nakita si Peter John eh.
Hello sir, rinig po ba?
Oo. Ano yung tinatanong ko? Don't answer the question. Ang inaano ko is, what am I asking for you? What am I asking the examiner? The examining here.
For the first bullet po, parang ang pagkakaintindi ko po dun is, ano po yung mga gram-negative
Very
oxide?
good. Yun ang tinatanong ko. Very good. Okay? O, since you've already understood my question, what's the answer to my question?
Moraxella, Neisseria, pati Veillonella po.
Veillonella. Very good. Moraxella, Veillonella, and Neisseria. Okay? So those are the gram negatives that you will study in your of medical importance. Okay, mag-alala, hindi sila ganoon kadami. 3 lang sila class. No? Hoy, chill lang kayo. Hindi lang yan ang ano. Coxi pa lang yan, ha? Gram neg. Marami pa yun sa ibang ibang structures. Okay? So, which of the 3 exhibits a red fluorescence when you exposed to UV light? It is, who can answer the question? Marion. Moyo.
Yung Veillonella po, sir.
Okay, Veillonella. Okay, previous name, maybe, baka mamaya makalimutan ninyo. Previously, Moraxella was known as Branhamella. Okay? So please be mindful if you see terms, if you see the word, if you see the family name, the previous family name, Branhamella, that refers to Moraxella. Moraxella catarrhalis and Veillonella parvula. Okay? Veillonella parvula is usually the one that fluoresces under red light. Okay? Mind you, we isolated that last week. Mind you. Okay? Now, let's move on to the next part of our discussion, which is, of course, gram positives. Of course, we're talking about gram negatives, right? We're not going to talk about gram positives. Okay? Can you show me the next slide? Can you show them the next slide? Okay, so examples of medically relevant gram-positive aerobes. Okay, so what I'm asking for is aerobes. So this includes your Micrococci species, Staphylococcus, and Streptococcus. For the anaerobes, it sounds similar. You just add what? Peptostreptococcus, Peptococcus, and Sarcina species. The only thing that's different is Sarcina. By the way, class, you have 2 species of Sarcina that you might need to remind yourself of. Sarcina lutea and Gaffica tetragina. Okay? You might hear these 2 things. Okay? So, ano ba spelling, sir? Ano ba yung mga pinagsasagot? Grabe naman to si sir. Ang dami namang pinapaalala sa amin. Class, microbiology to class. Kumbaga, in every subject that you will take, microbiology is the one that you will have a lot of stuff to remember. Okay? So, ano yung species na important sa ating dalawa ay sa kanila? Under Sarcina species? Sarcina species. Hindi ko nadagdag dyan eh. Kala ko yung edited version yung binigay ko sa inyo. Gaffica tetragina and Sarcina lutea. Why? Bakit sila important? Kasi in your ASCPI certification, they would differentiate Gaffica tetragina from Sarcina lutea. What's the difference? Gram stain wise, Gaffica tetragina, from the name itself, it has 4 tetrads. Okay? 4 tetrads. 4 na spaces. 4 na cocci ang makikita mo usually in the pattern. While Sarcina lutea will have 8. Okay? Will have 8 tetrads stuck together most of the time. Okay? Depende kung gaano kayo kaganda mag-smear ng sample or ng suspension. Okay? So, Micrococcus aerobes, when we're talking about aerobes, we have Micrococci, Staphylococci, and the Streptococcus species. Peptococcus, Peptostreptococcus, and Sarcina is the other one. Okay? Nalooban lang sa akong computer. Wait, hang on one sec. Patay. Na-disconnect ang isang lecture. Naloka. Yung nagla-live. Naku, naloka. Okay. So, because we'll be doing that, let's go to the next slide. This is slide number 13. Okay? Okay, you already know that thing, right? Let's go to the next one. Again, what I'm asking for, what am I asking for here, Al-Jabbar? Don't answer the question, the 11 organisms yet. What am I looking for here?
Bacilli that are gram positive.
Very good. Okay. Very good, very good. Okay. So bacilli that are gram-positive. Very good. Okay? Okay pa ba yung ano natin? Ay, naputol nga siya. Okay ba ba yan? Ay, okay pa siya. Okay pa pala siya. Alright. So, which of the following are aerobes? So last time na nagturo ako, nalilito yung mga students. Let's see kung ganun pa rin kayo. Who can answer the 11 organisms there? Gemoyo. Let's start with aerobes
Sir,
first. Let's start with
aerobes
aerobes.
muna, sir.
Ah.
Sir, Bacillus po, Cyanobacterium, Erysipelotrix, Listeria, Nocardia, Mycobacteria, Lactobacillus, tsaka Rothia po.
Cortia. Okay, very good. What about the anaerobes?
Clostridium po, Propionobacterium, tsaka Actinomyces po.
Okay. Very good. Okay, very good. Okay, so medyo may problem lang kasi gusto ko yung way ng pag-memorize ko para hindi ako mahirapan. Okay? By letter ako or by alphabetical order. I think Listeria and Lactobacillus yan. So, okay lang din kung gusto niyo gumagamit masyado ng maraming brain power. Pero for me, I will teach you something that I never told my students. Huwag niyo kakalimutan si Bakla. Bakla. Tingnan niyo class, tingnan niyo ha. Bakla. Tingnan niyo, Bakla. Murno. Diba? Murno. Oh. Para hindi niyo makalimutan. Bakla, Murno. Dalawang L ang Bakla. Okay? Bacillus, Corynebacterium, Erysipelotrix, Listeria, Lactobacillus, Nocardia, Mycobacteria, Nocardia, and Rothia. Okay? That's part of the 11. Actinomyces, huwag niyo makalimutan, ACP lang or PAC. PAC. Ano yung PAC? Clostridium, Actinomyces, and Propionibacterium. By the way, class, Propionibacterium is now known as who knows the contemporary nomenclature for Propionibacterium? Or Propionibacterium, sorry. Propionibacterium. Specifically Acnes. Cutibacterium. Ay, ang arte, sir. Kasi, para hindi nyo makalimutan, CAC na siya ngayon instead na PAC. Okay, CAC na siya ngayon. Okay? CAC. Cutibacterium acnes. So, pag marami kang Cutibacterium, ibig sabihin hindi ka na cute. Okay? Ganun lang yung para hindi nyo makalimutan. Okay? Kasi baka palitan na nila. Diba? Sir, ano ba yan? Kailangan din namin alalahanin. Of course. Ganun tayo eh. Ni-etchos tayo ng PRC eh. Okay. Or ng ASCP eh. Most likely sa ASCP papalitan siya, pero knowing PRC, even Ma'am Judea, I think, and the other review centers would say that it would take a long time before they change their questions. Diba? Apollo nga yung ginamit nila noong time namin. Si Apollo, hindi sinulat yun, 1999 pa. Diba? Okay. So yun. Let's go to the next one. Fungus-like bacteria. Fungus-like bacteria, are they fungi? Sometimes actually we would encounter this in the hospital that I'm working in right now. And I thought that it was hyphal structures, what I'm looking at, but it was actually bacteria when we ran it through the through the ID machine. We call it the ID machine, which is basically MALDI. So when we run it for ID, we'd say, bacteria pala siya kasi paano ko nasabi? Kasi Actinomyces ang nakita or Nocardia. Okay? So yun yung answer. Nocardia and Actinomyces. Okay? Next, let's go to the next one, which is the unstainables. Okay? The unstainables. Spirochetes. Okay? Ano yan TBL? Tomboy, bakla, lesbian. Hoy, okay, ganyan. Okay? TBL. Yan, tomboy, bakla, lesbian. Who can answer the 3 species of spirochetes that are of medical importance to us medtechs? Sige nga. Kung sasagot ng tomboy, bakla, lesbian, ha? Ano? Sino makakasagot? Who can answer that one? Ayoko na si Moyo. Baka sabihin may favoritism ako. Ayoko na si Marian. Ano yan? TBL na yan. Binigay ko na nga kayo ng shortcut eh. Talaga. Wala. Aaron Kirby. Abigail. Sige, si Dorothy. Ay, si Dorothy. Nandito pala si Dorothy. Hi, Dorothy. Si Dorothy muna. Yan ba yung Dorothy
Sir
na kilala ko?
Treponema borrelli
Ay, yan. Siya nga yun. Same ano din, same wall wash.
and Leptospira po.
Okay, very good. Treponema, Borrelia, and Leptospira. Okay, wonderful, wonderful, wonderful. Okay, so what special term is used for their flagella? They have what you call axial filaments, okay, or periplasmic flagella. Can you show the answer? Okay. So without looking at the next slide, we can answer this one. Treponema pallidum causes what? Serology also. We test that one with serology. Treponema pallidum. Naku, nakalimutan na nila. Borrelia burgdorferi. Okay. Ariane.
Syphilis po, sir.
Okay. Borrelia burgdorferi. Who knows what is caused by Borrelia burgdorferi? Or what disease is caused by Borrelia burgdorferi? You can get it from a tick. A bite from a tick. Ito yung takot na takot ako nung nag-move ako dito sa US. Takot na takot ako dito. Shira.
Lyme's disease po, sir.
Okay, Lyme disease lang. Chill ka lang, isa lang. Lyme disease lang. Chill ka lang. Shira, chill ka lang. Lyme lang. Nakakatakot. Gusto ko na tuloy ano. Yan yung reason kung bakit ayoko sa first floor. Kasi may mga, pag nung nag-move ako dito, ayoko sa first floor. Bakit, class? Kasi yung mga tick na yan, nandun sa mga puno yan, class. Okay? Malay mo kung makagat ako ng mga tick na yan, di ba? Kaya hindi ako kumukuha ng apartment na nasa second floor, na nasa first floor or second floor. Usually nasa tayo, nasa third floor. Kasi hindi abot ng puno. Okay? Kasi mamaya may masamang hangin na dumaan, may daladala ng mga may daladala ng mga ticks. Ay, nagkaroon na kagat ako. Baka bukas meron na akong Borrelia burgdorferi. Di ba ang arte ko na ngayon? Dati ang problema ko, Leptospira. Pag binaba. Di ba? Si Sir Manuel yung social na. Borrelia burgdorferi na ang problema. Hindi na Leptospira. Di ba, Patrick? Okay? So, spirochetes. Hindi yan spirochetes ha. Spirochetes yan. Okay, so yun yung tatlong spirochetes na i-discuss natin. This is just for general, okay class? Since we're talking about gram stains and the structures of microorganisms. May nagtaas ng kamay. Sino yun? Wala? Okay. Okay, it is known that spirochetes generally cannot be stained. However, some can exhibit a gram reaction. Spirochetes that have a gram reaction are what? O, diba? Ano siya? Ano sila, class? O, sige, Marian Castro.
Gram negative po.
Let's see if she's correct. Can we show the next slide? Very good. So she is correct. It is spirochetes that can be stained. If there is a possibility that the stain will be retained by the organism, if there's any technology or any type of new research that we could do, they are gram negative because they lack what? They lack the peptidoglycan layer. Okay? Alright. Next. The term given to gram reaction of mycobacteria. Ooh, I like this one because this is usually a cause of confusion for many of my students. Sige. Si Patrick, nasisipat na ni Patrick yung yung sagot. Kaya hindi ko tatanungin yan si Patrick. Nasisipat na niya yan eh. Diba? Yan ang gusto ni Patrick. Pero Patrick, kinig ka ha. Kidding ka, Patrick. Ayaw na kitang makita next year, ha? Last time na natin to dapat, Patrick. Sasampalin lang ka, Patrick. Okay. So what's the term given to the gram-stain reaction for mycobacteria? It is gram-ghost. Okay, tagal eh. Sorry, Marian, ang tagal eh. Gram-ghost. Yes, the term is gram-ghost. Okay, the term given to the gram-stain reaction of mycobacteria is gram-ghost. Okay, gram-ghost or gram-neutral. Okay, now let's move on to the next slide, which is, aside from mycobacteria, which other bacteria can be considered acid-fast, or we coin the term partially acid-fast. Okay? We have what? We have three species of organisms there. We have Nocaria. Under Nocaria, you have Actinomyces and Nocaria asteroides. Actinomyces israeli and Nocaria asteroides. And then we have Rhodococcus. Then we also have Legionella myctidae. Okay? So those are the organisms that you might encounter when we're talking about partially acid-fast bacilli. Okay? Bacilli, the oxide, partially acid-fast bacilli. Now, let's talk, since we're talking about acid-fast organisms, we'll talk about acid-fast parasites also. Just a quick recap. There are actually three. This is an old lecture, by the way, class. So, pardon me if I did not include the other one. Okay, this was written in the 2000s, in the early 2010s. Okay, so this lecture, this slide was we just add on to these things. Okay, but unfortunately I wasn't able to add it since the last time I used it. Okay, so the parasites that are known to be acid fast, we have three now instead of two. We have Isospora, Cryptospora, and Cryptosporidium, and Cyclospora. Okay, Cyclospora, Isospora belli, Cryptosporidium parvum, and Cyclospora cayetanensis. Okay, these can only be seen in patients with fulminant or end stage, or with fulminant AIDS. Okay, hindi na yung HIV positive lang. Okay, there are several stages to become an HIV, to the HIV infection process. First part is you just become HIV positive, and then you become an AIDS patient. How would you characterize as an AIDS patient when your CD4 levels are low? How low? Less than 200. Okay, less than 200 CD4 positive cells per sample taken from you. Okay, and that thing goes to a flow cytometer. And I'm not going to delve deep into that one because, child, we are talking about bacteria. Okay, all right. Now, let's move on to the next slide, which is all gram-negative bacilli are aerobes except for two. Talaga, sir? Sino yung mga yan? We have Fusobacterium and Bacteroides. Okay? There are three species of Fusobacterium that we'll talk about, one of which is Fusobacterium nucleatum, and the other is Fusobacterium necrophorum. Okay? We'll differentiate that when we talk about them, but just like a taste test, you'll know that the anaerobes that we'll talk about that are of medical importance is Fusobacterium nucleatum and Fusobacterium necrophorum. There is another one, but that is rarely talked about. So we'll get there when we talk about them. We have Bacteroides fragilis also. Okay. We'll go to the next slide, number 21, because there is a separate lecture for these two ones. Okay? It's like a 15-minute lecture. And if you don't get to that, you guys know my lecture, where my lecture's at, right? Some of you are my followers in YouTube, right? On YouTube. So you'll see it there if we didn't get to it. Okay? Anyways, let's talk about the two types of AFD staining. There are two types of AFD staining. We already know about this class, right? The cold and hot method. But I want to be specific. So if I were to be specific, we have Zil-Nielsen and Kin-Yu-On, right? Can you show us the answer? Yes. Zil-Nielsen and Kin-Yu-On. So the two types of AFD staining, Zil-Nielsen and Kin-Yu-On. Hot method is Zil-Nielsen, cold method is Kin-Yu-On. Alright? Next, mordant or intensifier, used in each of the two types of AFD staining. So the mordant that we use is steam for Zilnielsen because it's hot, and we use Tegretol for Quinone. Okay? Okay? So, masyado ba mabilis, class? So, for Zilnielsen, we use steam. Okay? Yun yung palalabasin ko lang yung spirito daw. Sabi ng aking butihing mentor when I did my first AFD stain. Palabasin mo lang daw yung aswang. Makikita niyo yun kapag i-steam nyo na yung sample nyo with the help of carbofusion. Okay? And then we use for Quinone, the cold method, the one that we use here in the United States is Tegretol. Bakit hindi na kayo magamit, sir, ng Zilnielsen dyan? Kasi social na hindi. Charet lang. Kasi available naman yung Tegretol. At saka kasi, naka-negative pressure na yung mga biosafety, yung biosafety, namin dito, medyo social lang. So, may negative pressure na sila pag AFD lab. Sa AFD lab kasi, naka-separate yan from main bacteriology. Okay? Bakit? Kasi hindi gagana ang pang-apoy natin. Kasi yung oxygen, mabilis yung turnover. Kumbaga, may turnover na tinatawag dyan. So, we'll talk about that when we go to the biosafety cabinets, or the labs rather, biosafety labs. Let's go to the next one, which is number 23. What decolorizer is used in AFB staining and how is this made? Naku, patay tayo dyan. Diyan kami nagkaloka last year nung nagturo ako sa mga kaklase ata ito nila Mark Segi. Nandiyan ba si Mark Segi ngayon? If you're here, pakigalaw ang bote. Wala na siya. Graduate na.
Nagpahinga po doon muna.
Okay.
Pahinga
Pahinga muna sa kalokohan ni Sir Manuel. Okay, alright. Anyways, how is this made? Ayan. So let's start first with the first question. What decolorizer is used in AFB staining? Sige nga. Anybody may nagtaas ng kamay? Marion Costes.
Ano po, sir? 3% acid alcohol po.
Alright, wonderful. And assuming we're making 1 liter of 3% acid alcohol, how do we do this? What is our solute and what is our solvent? Sige. Hindi na ikaw mo yun. Iba naman. Sige nga. How do we prepare this? O sige, si Marian nakataas ang kamay. Marian, how do we prepare acid alcohol? 3% acid alcohol. Sabi niya sabi ni Moyo. 3% daw eh. So, 1 litro ang kailangan ko. Good for 1 week na yan. Sige nga.
Ano, sir? 970 ml ng ethyl alcohol.
Okay.
Tsaka 30 ml ng hydrochloride.
Hydrochloride?
HCl.
Ano yung HCl? Hoy, chill ka lang. Ano yung hydrochloride? Hydrochloric acid.
Ayun.
Concentrated hydrochloric acid. Yan yung umuusok, class. Yan yung umuusok. Okay? So, medyo mahirap pagawin yan. Oo, pag natapunan ka yan, tunaw ang katawan. Tunaw ang balat mo. Okay? So, kaya 3% ang ginagamit natin. Charing lang. Para kasi kasi pag ginamit natin yung concentrated version, not only will you cause a hazard to yourself, you'll also you'll make it a hazardous environment for the mycobacteria. Wala na matitira dun sa microorganisms. Natunaw na. Di ba? So, yun. So, kailangan natin ng 30 ml of hydrochloric acid. Naloka ako kaya nahawa ako sa kanya. So 30 ml of your solute, which is hydrochloric acid, and 970 ml of ethyl alcohol. By the way, this is the units are misspelled. It's supposed to be small L, ha? Hindi yan megaliters, ha? Okay. Next slide, please. What is the most commonly used counter stain in AFB staining? What other stain may be used? The commonly used AFB counter stain is methylene blue. But if you are in an area where people are rich, you can use malachite green. Anong pinagkaiba, sir? Mas mahal kasi daw si malachite green. Okay, kung medyo nakakaluwag-luwag ang laboratory ninyo, malakite green daw ang ginagamit. Pero I think the first time, the only time I saw malachite green, kasi even here, and even when I was in the Middle East, methylene blue talaga ginagamit namin. The first time I saw malachite green as the counter stain is in the Philippines pa, when we were looking at positive samples for TB dots. Okay? Akalain nyo, sa Pilipinas pa ako first time nakakita ng malachite green. Diba? So, anong pinagkaiba? Methylene blue, ang background obviously is blue. Malachite green, green ang background. Yun lang ang pinagkaiba. Okay? Anong AFP positive? Sir, red. Okay? Red. Okay? Walang ibang color, red lang. Okay? Okay. Now, we can use other acids, by the way, to decolorize your AFB, to decolorize AFB slides. But this is more mainly for demonstrating weakly acid-fast organisms. Okay, so you can use 1% sulfuric acid as a form of modified acid-fast staining. Okay, and one question that keeps appearing in the Philippine board exams or your RMT board exams is the next slide. But let's answer this question first. What other acid may be used? It's 1% sulfuric acid. The purpose is for demonstrating acid-fast bacilli. Okay, weakly acid-fast bacilli. I mean, right? So like, what are the examples of weakly acid-fast bacilli or organisms? Saka na natin pag-usapan. Okay. So, next slide tayo. Alright. So, weakly acid-fast bacilli like Nocardia. Okay? Actually, para hindi kayo mahirapan, yung mga weakly acid-fast bacilli na yan, sila din yung mga tinatawag nating fungus-like bacteria. Okay? You would oftentimes see Nocardia asteroides. Or you would often see additional requests for fungus-like bacteria. Pag nakita ng, for example, you're working in a laboratory that does Nocardia cultures, you would often see partial acid-fast requests also. If the doctors are reaching a diagnosis that, oh, maybe this is not a fungus, okay? Because they might cause bacterial mycetomas, which is like a fungus-like infection, but it's caused by a bacterium like Nocardia or Actinomyces. That's something that will be discussed to you guys probably in mycology, and our purpose here is for more or less for bacteriology. Okay, so yeah, 1% sulfuric acid, weakly acid-fast bacilli. Okay, so we're done with that one. Let's talk about slide number 26, which is about the ideal smear. Okay, the ideal size of the smear is at around 2 centimeters by 3 centimeters. Okay, please be mindful na yung yung template yan nag-cause ng capital letters, hindi yan capital letters, small letters dapat yan. All right, next slide please. Or by the way, 2 by 3 centimeters is actually the size of an average Filipino person's thumb. Okay? Sinabi ko na lang Filipino person's thumb kasi I met a lot of people who are 6 foot and above. Malaki yung kamay nila. Kasing laki ng slide yung thumb nila. So, an average Filipino person's thumb na lang. So let's be specific kasi through my experience, hindi na pwede yung thumb size pag nasa ibang bansa ka na. Lalo na yung mga European na mga sobrang tangkad, mga people of European descent. Okay? So, let's go with number 27. What is the function of the polysaccharide component of the bacterial cell? So, it inhibits phagocytosis, okay? And there are 3 organisms that are associated with a polysaccharide component, or what we call the capsular component of microorganisms, and this is usually seen in both in some gram-positives and some gram-negative organisms. Of importance for us because we're medtechs and we work in the medical field. This includes organisms like Haemophilus influenzae, Neisseria meningitidis, and Streptococcus pneumoniae. Let's go to the next slide. I want the people to see first what is going on here. Okay? So, what do you think is common between these three organisms? I've always asked this every time I would deliver this lecture for bacteriology. What is common with these three organisms? Has something to do with the disease that they cause. They are all what? They are all pathogens that are related to anybody? May itis sa dulo. Para ano? Kasi lahat naman ng mikrobyo merong itis sa dulo kapag ka nagkaroon ng infection, di ba? Anong problema sa kanila? Tingnan nyo si Neisseria meningitidis. Anong meron sa kanilang tatlo? Anong common sa kanila? O yan na, si Claire Gono. Pumapalag na to si Claire Gono. Hi Claire Gono, it's nice to see you again. It's nice to see your forehead again, sorry. Anong klaseng meningitis? Meningitis, pero what type of meningitis? There's several types of meningitis. It could be fungal, it could be viral, it could be traumatic. What type of meningitis?
Hindi ko po alam kung ano.
Bacterial, syempre. Ano ka ba? Bacteria yung pinag-uusapan natin. Ikaw talaga, Claire Gono. Niloloko mo ako, Claire Gono. Parang hindi mo alam. Ayun, yung bacteria na yung nasa harap. Ikaw talaga. Sinachar lang kita. Oh, okay, so these three are the organisms that are associated with bacterial meningitis, commonly associated with bacterial meningitis. Bakit class? Kasi because of their carbohydrate or polysaccharide components, or the polysaccharide components or bacterial polysaccharide component, they are capable of resisting phagocytosis. Okay, and they can pass through the blood-brain barrier. Okay, they can pass through the blood-brain barrier. Okay? Okay? Clear ba tayo doon? Clear tayo, class? Okay? So, Bacillus anthracis is the next one that has a special component. Let's show them the next slide. Bacillus anthracis is the next one that we have to talk about. Okay, Bacillus anthracis has what you call a polypeptide D-glutamic acid component. And this has something to do with its pathogenicity also, or protecting the spores. Okay, so next slide. Okay, site of production of bacteria, of a bacteria, and the site of production of a eukaryotic cell. Let's go back first to biology 1. I'm going to ask somebody from the class. Alam ko na. Every year, lagi ko tinatanong, every time na nagtuturo ako, lagi ko tinatanong ang moderator ko. Last year si Sekia, tinanong ko. Let me see if you are still familiar with Biology 101. Okay. Patrick, what cells do you have in your body? Do you have eukaryotic cells or do you have prokaryotic cells?
Eukaryotic cell.
Bakit?
Kasi yung prokaryotic yung sa plants eh. Kasi eukaryotic yung sa animal.
Hoy! Plants are eukaryotic. Naku, Sir Marco, bubula yung bunganga mo talaga pag narinig mo sinabi. Every year talaga pinabubula ng mga moderators ko. Every year yan lagi ko tinatanong. Huwag ka mag-alala, every year din mali din sila. Huwag ka mag-alala, hindi ka naiiba.
With the prokaryotic plant.
Hoy, sasapaling kita. Okay, Marian. Marian, what's the difference between what are you? What cells do you have? And explain why, Marian.
Eukaryotic cells po.
Bakit? Ano ba ang pinagkaiba ng eukaryotic sa prokaryotic?
Yung eukaryotic po kasi may distinct nucleus siya na kung saan yung cells may genetic material. Tapos yung prokaryotic naman po, wala siyang nucleus, pero meron siyang free-floating genetic materials instead.
Free-floating, okay. I wouldn't say free-floating, free-flowing or free-floating. I would say they would be found in a specific structure that's not in the nucleus. let's go with that one. But you are correct. You are an organism that is composed of millions, if not trillions, or if not hundreds of billions of eukaryotic cells. So tandaan mo, halaman ha, pwede. Hoy, Patrick, halaman pwede ding magkaroon na. May ang mga halaman eukaryotic din sila kasi merong nucleus. Okay, pag sinabi natin prokaryotes, that is before what? Before, from the word pro, before karyo, which is nucleus. Okay? Eukaryotes is the present, meaning now, plus nucleus. Okay? So ano ba yung mga now? Yung mga evolved na, or what are we talking? Before and after? Ano ba yung mga ganon? Ay, before and now. Ano ba? Bakit ba before and now? Kasi they are speaking in the evolution, from the evolutionary standpoint. Okay? Evolutionary microbiologists or evolutionary biologists named these terms based on the fact that they believe, they think, or they postulated. I don't want to use the word believe. I would rather we go to the scientific route and say they postulated that all organisms in this world took billions and trillions of years, and they have all originated from eukaryotic organisms. And you would see that with the mitochondria. We'll talk about that one later. Okay, the site of energy production of bacteria is in the cell wall, or the cytoplasmic membrane. Sorry, it's in the cytoplasmic membrane. Whilst for eukaryotic organisms, it is in the mitochondria. Remember your Krebs cycle, class, right? Remember your Krebs cycle? So it happens in the mitochondria. For bacteria, the Krebs cycles happens in the cytoplasmic membrane. You would see that the appearance of the mitochondria resembles, if you look back at your old books, you would see that the appearance of most descriptions or depictions of the mitochondria, either through an electron microscope or through an artist drawing or depiction, it almost looks as if it was a bacterial cell, right? So if you study biology from its very roots and look at it from the evolutionary standpoint, the fact that eukaryotic cells right now, or eukaryotic organisms right now, are capable of producing energy through the mitochondria is thanks to bacteria. Because bacteria were the ones that first started to utilize energy in the form of ATP. Okay? So, as I was saying earlier, what I was mentioning earlier to Marian, I can't remember if it's Claire, Gono, or Marian earlier who answered the question of what is the difference between eukaryotic and prokaryotic organisms. Next slide na tayo, Patrick. This is the point where the genetic material of bacteria is attached. I didn't say it is free-flowing because there's a certain point in the bacterial cell that has the genetic material, and this is known as the mesosome. Okay? Next slide. The answer to that one is the mesosome. So unlike us, when you look at your cells, in the microscope, you'd always see a nucleus. But for bacteria, it isn't quite as simple. Okay, imagine bacteria. When I was reading through it and when I was reading through what was a mesosome and stuff, it looked as if it was like a zipper. Okay, only the mesosome acts like a zipper that creates the new cell or another cell when it's undergoing cellular division. Ganun yung nakikita kong ano na kanya. Kasi ito ang nangyayari kasi class sa bacteria, di ba? They multiply or they reproduce through binary fission, right? Most microorganisms that we're going to talk about, they multiply through binary fission, except for organisms that have a sexual pili, like Neisseria. Okay, so through binary fission, I saw the term mesosome, and it looks, in the drawing, it looks like the genetic material is being exposed to the outer part of the cell, and the copies of the cell wall, or the copy of the new cell wall, or the other organism that is going to be produced, originates from the mesosome. Para siyang zipper. Di ba yung nakikita niyo yung mga codes, genetic codes ng mga organisms natin? Naalala niyo ba yun yung may mga codons? Yung A, G, T, yung mga ganon class. Yung mesosome na yan, pabilog yan. Tapos parang umiikot-ikot yan na gano'n kapag ka nagkakaroon ng binary fission. Tapos parang zipper yan, may lalabas na isang strand, and then yun na yung nagiging simula ng bagong copy ng another cell. Okay? But that's deep microbiology, or that's deep bacteriology, bacterial physiology. If you want to know more about that, a good read would probably be Bailey's and Scott's. Okay? So let's move on to the next one. Inclusion bodies that are found in medically important bacteria is what you call Much granules. We have Much granules, Berg's Ace granules, and bipolar bodies. And these are seen in 3 types of microorganisms. Much granules are seen in Mycobacterium tuberculosis, Babe's Earth granules, also known as metachromatic granules, or what you call voluted granules are seen in Corynebacterium diphtheriae, and the other one is bipolar bodies, which is seen in Yersinia pestis. Bipolar bodies makes it appear that Yersinia pestis looks like a safety pin bacillus, by the way. Okay? So let's talk about them one by one. Staying used to demonstrate bipolar bodies, we have what you call number 32 na tayo. Patrick. Okay. Sorry. Nubo. Okay. So staying used to demonstrate bipolar bodies include your Wason stain. And this makes it appear that the Yersinia pestis would have the appearance of a safety pin. Ano yung safety pin, sir? Yun ba yung may sa taas? Hindi. Yun yung pag sobrang nabusog ka sa sabog yung botones mo, kailangan mo ng partible para isara yung uniforme mo. Okay? Yun. Okay? Safety pins ang tawag doon. Partible. Tama ba? Partible ba o perdible? I'm not sure. That's deep Tagalog for me. Okay. Partible. Partible, Patrick.
Perdible, sir.
Perdible. Ang arte, di ba? Very parang nahawa ka na kay Sir Marco, ha? Arte magsalita yan si Sir Marco, eh. Nahawa ka na kay Sir Marco, ha? Parang mga tagadela sa lang ito magsalita. Alright, let's go to the next slide. Very ponyo, perdible. Okay, so staining methods may be used in order to demonstrate voluted granules. There's 2. We have the lamp stain and the Burke's stain or Burke's method. Both of them they use methylene blue. I don't want you guys to delve deep into what they are, but I want you guys to know that volutin granules or Babe's Earth granules from Corynebacterium or metachromatic granules, from Corynebacterium can be demonstrated using methylene blue with Blam's and Burke's method. Okay? So I don't want you guys to remember that one. I've never seen that in the exams. But what I would like you guys to remember in this slide, I want you guys to take in from this slide is the methylene blue. Okay? That is used to demonstrate those things. Okay? Next. Sorry. This is a structure that is found in some bacteria that is considered as a resting cell, which allows the organism to survive under extreme conditions. Under extreme conditions, in the end, to extreme conditions. The chemical component of these structures, they have, this is what you call bicolinate, calcium dipicolinate. And the structure that we're talking about is a spore, okay, or an endospore, right? It's not like the spores that we have in. Bakit, Patrick?
Okay, sir. Sorry, nag-raise na attention, sir, kasi parang nag-delay yung meeting sa live po. Nasa 34 pa lang.
Talaga?
Oo po, nasa 34A.
Nasa 34A tayo.
Yes po, sir.
Sandali. Di pwede yan. That's not good. Ano nangyari? Hala, na-close ko. Gumagalaw pa tayo, Patrick.
Naka-stock po 34, sir.
Patay tayo dyan. Na-close ko.
Sige, sir. Ito lang ulit.
Sandali. Gumagana pa naman siya dito sa isa. Let's see. Ayan, okay na. 34A pa rin. 34.
34 pa rin po.
34 na hindi nagbago. So let's just end this one and let's start another one. Fine? Okay, so we'll just put